So this is a video on how to derive the total resistance equation in series and parallel circuits. So this is for series circuit and you have to justify why you're doing each step. So using Ohm's law that current is directly proportional to potential difference, and Kirchhoff's law 1 that current flowing through each resistor is the same, you write V1 equals IR1, V2 equals IR2, V3 equals IR3. So the second step is using Kirchhoff's law 2, the sum of voltages in series equals the supply PD, and you have to write V equals V1 plus V2 plus V3. The third step is you have to replace the individual PDs using the Ohm's law from the first step, and you write V equals IR1 plus IR2 plus IR3. This is basically substitution of the first step into the second step. The fourth step is factor out the current, so I, from the previous equation. And the final step is rearranging this equation, and you know R equals V over I, so you just write R instead of V over I in the final step. And so this is what the whole process will look like for series circuit. So for parallel it's a bit different. You have to use Ohm's law and Kirchhoff's law 2. PD across each resistor is the same as supply PD. And then you use conservation of charge, which is the total current is the sum of the individual currents. So I equals I1 plus I2 plus I3. Step 3 is a bit similar to step 3 in series circuit. So you replace the I's with Ohm's law. In series you replace the V with Ohm's law. So step 4 is a bit complicated, but it's the same principle as series circuit. So you factor out V and then you make V the subject, and you have to remember in the second step it's I times 1 over R1 plus 1 over R2 plus 1 over R3. That's a difficult bit, and then you rearrange to get V over I, which is basically R, and then this is the same as. So this is basically the same as the equation you're familiar with, 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. And this is the whole process. Thanks for watching and good luck revising.